Welcome to today's presentation, Continuous Delivery, Every Team, Every Change, incorporating all change events across all teams. Let's go ahead and get started. Scott, over to you.
Thanks, Aaron. I'm really excited for the opportunity to discuss continuous delivery, as I spent the last 5 years at Chef helping our customers with CD almost as much as Chef automation itself. So we at Chef have always been bullish with our customers that you really cannot achieve success with automation at scale unless you adopt these best practices. We have a lot to cover this hour, so we really need to go ahead and jump right into it. Our presentation today will cover what challenges companies face right now in adopting continuous delivery by looking at the reality of the enterprise landscape in its entirety. We're going to go into how Chef helps clients and customers move their continuous delivery efforts forward, followed by a demo that Nick has prepared for everybody that's going to leverage our technology. And of course, we're going to save plenty of time for questions, Q&A at the end. So with that, let's go ahead and just jump right into it with a little bit of perspective here. So the term digital transformation is pretty commonplace these days. Across every industry, companies are either being founded with the principles of being software-driven organizations, and they use technology to provide continuous value to their customers. But for companies founded before the technology revolution, right? Companies that you wouldn't think traditionally as software companies. So you've got industrial manufacturers, banking and finance companies. You've got airline companies, restaurant chains, and more. For those companies, the choice it's clear. It's either adapt and evolve to be software-driven organizations, or you fail. And the interface right now between businesses and their customers are applications. Applications drive business value. They're how we keep our customers engaged, informed, and of course, continuously using our products, which drive revenue. And then all of this means that all companies must figure out how to ship more applications faster. But if we're going to ship more applications more frequently, with all this constant change comes risk. It would be really nice for us to be able to focus on creating and releasing new features for our customers. But the reality is it will never just be about new features. Companies must always have a plan for continuous maintenance on applications. So whether it be patching vulnerabilities in the systems that run our national power grid, gulp, or patching the software that runs our airplanes, the stakes are high and we need to get it right. Of course, Boeing made big news this year for all the wrong reasons when it was discovered that a catastrophic software bug was at the root for multiple commercial airline crashes. And software bugs are just one place in this complex puzzle that break down our ability to deliver change to our products. To truly look at this problem, we must go wider. So why is modern application delivery so hard? To start, application architectures are complicated and modular, yet those components are highly dependent, and the changes in one area can cause failures in another. Security and compliance are top of mind of any CEO, CSO, CIO, but often are killers in velocity inside the enterprise. And the responsibility for these different components of the stack fall to different teams that are siloed from one another, adding even more friction to velocity and increasing technical debt. So let's take a look at each one of these in a little more detail. Modern applications are complicated, right? We know this. They're multi-tiered. They have many components that are being deployed out. We've got different technologies that exist within the stack. As we said, they're modular, yet they're tightly coupled together. So, a change in a network layer can disrupt how an application flows. A change in configuration of the operating system or the underlying image that you're using can break an application. These applications are multi-cloud, so not just running in multiple private clouds, but more often than not, we're seeing applications that are being deployed both on-prem and in the public cloud. So they're extremely complicated. But one of the most important factors in gaining and retaining customers is trust. Customers have to know that you are doing everything you can do to protect them that you can protect them and their data. And no CEO wants to end up on the cover of the Wall Street Journal because they've exposed customer data either through a breach or some configuration or setting that could have been prevented. So security and compliance are a fact of life and critical to a business's success. But the solution can't be that we just slow everything down to be more secure. Yet for many organizations, that is just the case. For many organizations, security and compliance is implemented in a fashion that kills velocity. So it's also very common to see security and compliance organizations siloed within an enterprise and not integrated into the development process. Not having these critical people and teams at the table further kills velocity, which brings me to my next point, which is that disparate app teams are spread out all across our environment, right? So I'm sure right now, if you took a step back and thought about your environment, it might relate to you that there are teams that are, building brand new applications from the ground up, and they have big budgets and they're deploying into platforms such as Pivotal Cloud Foundry or into the public cloud. You've got teams that are refactoring or lift and shifting applications into containers and deploying those out into platforms such as Kubernetes. But then also inside your environment, there are many what we call legacy applications that exist that are still being maintained, and they could be being deployed out to traditional VM settings or even bare metal. And all those applications still need to be maintained. And even with some of the higher level teams that we're talking about here, the modern Docker, Kubernetes, Pivotal Cloud Foundry teams, some of the applications from the legacy environment are dependencies, meaning that they run on the systems that we deploy to. And so they are all related. And so all of this complexity in these disparate systems they bring a lot of challenges. So, but it's not just to the software that we are developing in-house. Both our applications and the environments that we build and deploy in also have dependencies on applications produced by vendors outside of our organization. So think about Microsoft.NET, Java applications, build systems, messaging systems, streaming technology. As Agile spreads across the industry, the rate at which new versions of those dependent apps are shipped to us is only increasing, which means organizations have to build a strategy for also consuming, testing, and releasing those versions into their environment. Now, I just zero in on Chef itself. As I mentioned, I've been at Chef for 5 years now, and we have accelerated so much over the last 5 years in our ability to ship our products out there. We continuously release new versions of Chef Automate to our customers live. We have new patch versions of Chef Client going out all the time. We release new major releases of our clients annually as well. And all the code that our customers write have to be tested against that. They have to be promoted across the environment and ensure that nothing's going to break. So that's just one example. But if you were to stop now and list out all the technology that makes up an application stack within your organization, would you really be able to do it? Would you be able to cover the technology that other teams are responsible for in the systems you deploy to, or just for the technology that you are responsible for specifically? And I bring up this point of understanding the true landscape of your application stack, because at an individual practitioner level, or even at an isolated team view, that view may be analogous to an iceberg floating on the sea. So from the horizon, one's perspective might be on the component or components they are responsible for. But underneath the surface, there are many other factors that can influence the stability of a given app. There are agents that get deployed, and those agents have vendor updates, there's security patches, there's base image changes, there's network changes, compliance requirements, et cetera, and on and on and on. All these also must be considered in the release of an application as we move from the developer's laptop to production. So how do we get to a path to production where all of these requirements can be tested together? Without a doubt, the single most impactful solution is through a code-driven process, right? Code-driven changes and the usage of continuous delivery. Continuous delivery is a set of capabilities, really, and those capabilities enable us to get changes of all kinds into production fast, safe, and reliably. Continuous delivery is what allows organizations to get both speed and security. It is through the usage of pipelines where we're able to define a path to production where changes can be peer-reviewed, automatically tested, audited continuously as they make their way out to production. If you're in agreement with what we've been talking to up to this point, though, continuous delivery is not just for modern application teams. Really, continuous delivery can be applied to any type of change, including application configuration changes, infrastructure automation, new features, bug fixes, and experiments that you want to get out. But whilst continuous delivery is gaining momentum, is it enough for organizations to implement continuous delivery in any fashion from team to team? As more and more teams adopt continuous delivery within the organization, without a holistic planning, we are prone to develop patterns where each team or even each component within an application stack can take a different path to production. We can have different teams using different technology underneath that, that pipeline itself. In our heads, we may be saying, yeah, we've got CD implemented across our environment. But in reality, it may look something a little bit more like this, right? Some pipelines have automated testing, some do not, some have automated deployments, some are still manual. Different teams use different tooling and different methodologies for measuring success. And without that consistency, it's hard to measure overall success in an organization. And this is not a small problem to solve. So the question becomes, before we get into this, it's really interesting to us to see like what CI systems are your organization predominantly using. So we've got some examples up here. I encounter all of these all the time. I don't know, Nick, in your experience out there, was there, you also come from an operations background, any specific tooling that you've used in the past?
Well, it's interesting. I didn't, my days in system administration was long enough ago that outside of a few Jenkins pipelines, I didn't see too much differentiation or even really implementation of CI. But what I did see ended up, I think, speaking to the complexity of building these things, which was I spent a lot of time working at like managed service providers for like web hosting. And we would end up taking on a lot of the operations tasks for our customers. And it meant I need to familiarize myself with a really broad array of technologies, from like deploying your Ruby on Rails apps with Capistrano to people's Octopus deploy scripts to configuring all of the back-end components that were needed to run those things, from web servers of all flavors, databases of all flavors. And as we get these larger and larger heterogeneous environments, I see that sort of just increasing, where there's just so many different things out there that getting them even structured in a way that we could create CI/CD systems can be a challenge.
Yeah, that rings true with me as well. I come from an operations background. Jenkins was definitely predominant in our environment. There was also some Bamboo with the Java developers and building their artifacts and getting deployed out. But it's been really interesting in the last even the last 12 months as I've been out there to see some of the effort that Microsoft is putting in around Azure DevOps as well. They're being pretty vocal about using Azure DevOps for other clouds, including their competitors. And so, I think there is a focus on a little bit of this tool reconciliation and finding a way of, can we land on one CD tool, that CI/CD tool that we can to build any of these projects. So we've done some Concourse work for some of our other customers as well, but which has been a fun product to jump into as well.
Right on.
So let's go ahead and jump over and take a look at some of the poll results. We've got some responding, and yeah, it's to be expected. I mean, I think Jenkins is still one of the most predominant tools we see out there. 61% of respondents are saying that they use Jenkins out there, and followed by, we've got some Azure DevOps is gaining some momentum, and Bamboo, and a lot of other. I'd be curious to know out there if anybody wants to add into the Q&A and talk about what other CI tools that they're using and if they're having success with it. So feel free to jump into the Q&A and share what's going on. We've got another poll for you out there before we move on, which is what percentage of applications within your org are being handled by automated pipelines today? This is something we touched on before as well, which is, they're as we travel around, and I for myself, I'm work in a global position, and I get the opportunity to work with customers all around the world and see what they're doing out there and across the landscape. It's definitely, this is on everybody's agenda, which is adopting continuous delivery, but within especially these larger enterprises that Chef really works with, it's a mixed bag, right? It's you've got a lot of the modern application teams that are fully bought in, but some of the operations folks are lagging behind. We're going to touch on some of that in just a little bit too. Nick, any thoughts on some of your experiences out there around the percentage of apps going through pipelines?
Well, I think it really, in my mind, it comes down to the importance of the breadth of your coverage, specifically when we're automating things. When I started using Chef, so this was a ways before I started working at Chef, it was in that same role where I was running an implementations arm of the organization I worked for, and we just had such a disparate set of tools among our customer base. Chef helped me standardize my process for how I would configure environments when I'd create them for our customers. But we didn't have our support team using Chef, nor did we do full management of those servers. So customers would log in and make changes and things. So when the support team would come and run the same recipe we ran to set things up, they would get really different results because so much had happened in the intervening time. And that's sort of same way with CI/CD. It speaks to the importance of making sure you have that end-to-end consistency, because if you're not doing at one end of the process the same thing you're doing at the other end of the process, you can't reap the same benefits from automation. Yeah.
Yeah, I totally agree with that. That's what I'm seeing as well. Let's go ahead and take a look at some of these results. So we've got 37%, it looks like, out there are somewhere between 1 and 25% of their applications are being handled via an automated pipeline, followed closely behind there. But it's great to see, but 51 to 75% of respondents are saying that they're 25% of you are responding saying that 51 to 75% of their applications are going through a pipeline, and split along with 26 to 50%. Now, this one too is actually interesting to me, the unsure, right? Because this is something that we're going to dive into a little bit more here today, which is that, it's very easy to get focused in on your specific world within an enterprise of we do things one way. I have no idea what anybody else does. I mean, some of these organizations we touch with, we work with 100-plus-year-old companies that are working on transformation, and they're spread out globally. How is it you're even to know what applications are going through? So we'll continue to touch on this, but I appreciate everybody going ahead and taking some time to respond to this. So, all right. So the question really becomes, how do we deliver continuously across all these various areas? We've got, different app teams, including, teams that are doing COTS applications and legacy applications and new applications that exist out there. We've got new changes that have to go out, new features, there's configuration changes, there's bug fixes, and all of this into any environment. So from team to any environment, which really brings us to this next section that we're going to dive into, which is how do you build a single continuous delivery pipeline that can work for the larger enterprise and start to be able to measure yourself on a much more macro scale. So Jez Humble, he's the co-author of the book Continuous Delivery, and he's also the co-author from the Dora Report. He's also a former Chef employee and has long been a vocal proponent of automating as much of the software delivery lifecycle for all areas of the stack, including infrastructure as code and stateful services and more. But in the quote that you're seeing up here on the screen, I want to key on one particular phrase here, which is from source control to production. It amazes me as I travel around and visit with enterprises all around the world and who are at various stages of digital transformation. And for those companies where source control is not the foundation of their DevOps journey, they believe in the concept of automation and DevOps, but that automation code still sometimes lives on practitioners' laptops or on a shared drive somewhere or a Bastion host that they log into and execute code from, right? But by not prioritizing source control as the source of truth for how change flows from the organization, it is impossible to implement continuous delivery and reap its benefits. And there are many aspects to implementing continuous delivery, right? So it always starts with people and process, but culture plays a big part as well. Continuous delivery at scale, though, it's going to involve a lot of people contributing across the enterprise, and those people will be contributing a lot of code. And this is the philosophy here at Chef. We've never been shy about this, as I mentioned right from the get-go, that code empowers us. It is the work that we do in the automation world. We are an automation company. That is software development. It's no different than any other software development that goes on inside your organization. It's with that software development process of automating your processes and moving them from left to right, from multiple contributors out through to production, that we're able to get trust and velocity. But it also, it really enables us to collaborate together. It enables us to shift left and catch bugs and security vulnerabilities early. We can learn from each other and continuously improve our processes. And all of this should hopefully make happier teams, right? I mean, we want to wake up and enjoy going to work. We don't want to spend our time on production outages in the middle of the night, and happier teams are going to build better products for our customers, right? So all this, the foundation is in this philosophy that code, it's a software problem for us to solve, and code drives so much of this. Now, traditionally, when enterprise look at applications, they've taken a bottom-up approach to deploying applications. So rack and stacking servers, installing operating systems that provide core system libraries or packages that our applications require to run, installing and configuring middleware before layering in those applications on top. This process was traditionally was very manual, right? It's dependent on human beings to implement, which is slow and it's error prone. And while manual application stack deployments still plague low-performing organizations, high-performing organizations, on the other hand, and have long addressed these challenges through the use of automation. And moving from the bottom up, right? Infrastructure as code has been around for a long time, and the infrastructure as code is really the process of managing and provisioning computer data centers from machine-readable definitions rather than physical hardware configuration or interactive configuration tools. These definitions, though, they should be stored in source control. And once they're in source control, those changes can benefit from the usage of CI/CD pipelines. Now, above configuration as code is this concept of security and compliance as code. And that builds on the benefits that came from infrastructure as code, but rather than definitions that change the system, Compliance as code focuses on definitions that translate policy to code so that systems and applications in our data centers can be continuously tested for security and compliance. This applies not only to systems running in production, but through the software development lifecycle in its entirety, right? So from the developer's laptop using security and compliance as code, I can test my changes before they ever leave my local development environment. So we can go from the developer's laptop through a pipeline all the way through to production and continuously test security and compliance changes and catch those failures before they ever get out into our various environments. Now, application automation as code looks specifically at automating all the lifecycle of deploying applications, from the build process where dependencies and transitive dependencies are defined, configuration, service binding, service discovery, lifecycle events like initializing, running, health checking, smoke checking, and even updating the applications themselves are defined as part of the automation process. It's literally defined on the left along with the application. So the code that it takes to build, manage, and deploy your applications lives with the applications, with the application itself. And now piecing together these various capabilities can be a daunting task, whether you're trying to find different tools that exist out there around the landscape, develop them in-house. But Chef Software has relentlessly pursued solving these challenges and with the release of 3 distinct products that address this. And those products are Chef Infra, which is what, I would say most companies, most people know Chef software for. Chef Infra is the concept of infrastructure as code. So a client that you can codify the standards, the packages, services, users, configuration files that exist on infrastructure and continuously run that code in Chef client will make sure that your infrastructure is always in the state that it's supposed to be in. For security and compliance as code, Chef has what's called Chef Inspec. And Chef Inspec is a testing framework that allows you to take standards, whether they be standards that are developed in-house inside your organization or standards that exist outside. So Chef, we have for our enterprise customers published all enterprise-ready inspec profiles for things such as the Center for Internet Security benchmarks, DISA STIGs. We publish benchmarks and testing profiles for CVEs and zero-day vulnerabilities that come out on demand. So this is a really exciting product that's gaining a lot of momentum out there in the industry. And then for application automation as code, we have Chef Habitat, which we're going to spend a bunch of time with today. And Nick has prepared a really cool demo for us. And Chef Habitat is a way for you to simply package up applications into an immutable artifact. And through the automation, we can define the dependencies, but also with that, we get all of the transitive dependencies that our application requires to run. So if we think back to that previous stack of like an operating system may be providing core libraries like glibc and OpenSSL and so on. And your application becomes tightly coupled to that operating system. With Habitat, we're going to be able to build artifacts that package up the version of glibc and OpenSSL that they were built with, along with the artifact, and produce truly portable artifacts that can be deployed anywhere. So with Habitat, it's the application, it's all of its dependencies and transitive dependencies, everything that's configurable about it, all of the lifecycle events. So how do you run it? How do you restart it or reload it if there's a configuration change? How do you smoke check it, health check it? All of that is a part of the artifact itself. So when we build this artifact, it can be exported into other formats, including Docker containers or running bare metal VMs, really wherever you need to run it. So we're going to dive into that a little bit, but it's today, but it's really, really exciting new product for us. So when we apply that view of a kind of traditional application stack and we layer that over with our products, you've got Chef Infra, which is we're really we're getting very prescriptive with how our product should be used. Chef Infra is a fantastic tool for configuring underlying operating systems. So whether that's Windows, Linux, Solaris, HP-UX, AIX, it doesn't matter. You have a framework that you can define the configuration, the hardening standards that are set for the operating system, and get it ready for what we use operating systems for, right? I mean, I'm a systems administrator, and my job was not to stand up VMs and systems because I like to configure Linux. It's because I'm getting ready to deploy applications. But applications are a different challenge to solve. There's questions that we have to ask about applications that traditional configuration management don't solve. And that's really where Habitat comes into play. So the ability to package up our application, middleware, packages, system libraries, all of that into an immutable artifact that will run anywhere and then be managed in the same way wherever that's deployed. And then throughout this all, no matter where you're deploying these applications, if you're deploying VMs or bare metal, or if you're deploying Docker containers, Chef Inspec is the way that we can codify any of those standards that we have and be able to continuously test all of our environments for security and compliance. So going back to this slide that we touched on earlier, right? So we've got inside of our organizations, we see lots of different shapes of pipelines. We've got lots of different technologies being used out there, and the paths aren't always the same. But using Chef and our automation kit, you can really, for the first time, get to this place where whether you're building infrastructure as code, security and compliance as code, or any application as code, you have a consistent way to go and build, test, deploy, promote an application through given environments and get it out and running into production. And once it's there in production, we have a consistent way that we can manage those applications. So my friend Nick has prepared a really cool demo that I think is going to touch on all this. Nick, what do you got set for us?
Yeah, so I think part of this really comes down to what you get from adopting these automation patterns. I'm actually going to hop back into that last slide for a second. The reason that our pipelines don't necessarily look like this today, where all of the different applications we manage have a consistent, at least, shape of deployment, is because they have fundamentally different underlying components, right? And that's what being able to standardize these processes gets us. Because historically, right, if you just take, for example, build, well, my Java apps are built with Maven, my Node apps are built with Node, my .NET apps, and so forth and so on down the line. So even if the job being done was the same, the way of doing it was different. And that logic lived directly in the pipeline. And that was, going back to our poll conversation, that was the big pain I felt as an operations professional, was I just kind of had to sort of know a bunch of technologies, but not really kind of have that sort of depth of knowledge for any specific thing, just because there was too much to manage. So ultimately, if we're able to solve that problem, and again, the way we're solving this in the case of something like Chef Habitat is by taking that logic and putting it into that application artifact directly. You've got your dependencies, you've got definitions of health, you've got, life cycle hooks, how to install, how to update. And that allows us then to treat that artifact consistently, regardless of the underlying technology, and get that consistent pipeline. Once we've done that, we get to start solving problems that we couldn't solve yesterday. And in particular, the problem that's living underneath that iceberg and always looming in wait, which is what happens when we need to update the things in the middle of our application stack, right? Patching an application dependency. This is something that has been very, very difficult to accomplish traditionally, partially just because even figuring out where in a large environment these dependencies live and need to be updated can be a Herculean task in and of itself. But then you have the issue of determining whether or not you can safely make that update, and if any applications you manage are going to need to change before they can consume it. And so that's going to be the theme of the demo today. So I'm going to kick off a screen share. And team, I'm going to ask you to keep me honest and make sure that everything is coming through. But once the screen share is loaded, y'all should see a web browser with a CVE, a vulnerability that we're going to need to deal with. So,
looking good, Nick.
Thank you. So today's vulnerability is going to be with a very important library in my software stack, libhelloworld. My job is to demonstrate things, so hello world is, my screwdriver. In this case, we have a problem. Any version of libhelloworld before version 3 is vulnerable to this codename Grammar Maven vulnerability. As a professional, just making sure things are running in my environment, really, I need to cut to the chase. What do I need to do here? I need to make sure I update to version 3.0.0 as soon as possible. All right, well, let's look at doing that. So here is libhelloworld in my depot. This is an artifact repository for Habitat artifacts. And indeed, I am building libhelloworld and, in fact, my entire dependency chain with Habitat. We have the ability here. I can see here that I am running an affected version. 2.4.18 looks to be the latest version I have available. But I also have this connected to source control. So in my source of truth in GitHub, it looks like there has been a change pushed. It says fix the grammar CVE. That's exactly what I want to do. So I'm going to go ahead and kick off a build of the latest version. Incidentally, you can set up auto builds if you're not running demos. So in this case, as soon as a new change was pushed to that master branch in GitHub, this process would have been triggered automatically. But now that we've gotten the ball rolling and my whole build process will take a couple minutes, let's take a look at what I actually care about. I have two applications that I run. One is called National Parks. This is a Java application. One is called Sample Node App, which is a Node.js application. And ultimately, these things need to stay running. These are the lifeblood of my business. If these go down, I'm not making money. I need to keep these online. I also want to make sure that I'm not vulnerable to this vulnerability. So I need a way to see whether updating libhelloworld is going to adversely impact either of these applications, which for me is going to mean I need to do some development work to update those applications so I can consume the change. One of the cool things about Habitat, and in particular the builder depot I'm using here, is that we have the ability to define automatic downstream builds. So what we're seeing here in this build job is right now we're building the latest version of libhelloworld, but there are two queued jobs for National Parks and Sample Node App. So I can actually tell right away what things sit downstream and have configured an automatic build so that once this new version is ready, we'll rebuild my apps and make sure that they build successfully with that updated library. If I didn't know that, or if I didn't have this set up, another feature of Chef Habitat is the ability to run it with a supervisor. And the supervisor is a sidecar service that, among other things, gives us an API endpoint that we can hit to find information out about our applications. Here, I'm going to my application, and I'm looking at Sample Node App in my development environment. And I'm going to look for the package dependencies information. And this is everything Sample Node App was built with, including, and we can see here explicitly, yes, there is libhelloworld, and yes, it is a vulnerable version. So this is a problem we're going to need to solve. Again, same thing for National Parks. Everything in that dependency chain, again, since National Parks is a Java app, we're going to see things like Tomcat in here. We're going to see things for web servicing like OpenSSL. And for each of these dependencies, I can tell exactly which version and even which release this version of my application artifact was built with. All of these dependencies are bundled into that artifact and travel with my app as it gets promoted through a pipeline. So here's my continuous delivery pipeline. You'll see I have one for both of these apps, and they're going to look pretty similar. And in fact, they're configured almost identically. Except for the names of the actual artifacts I'm promoting, there's no difference in the logic between these two pipelines, because that logic lives inside my application artifact. So what's going to happen here? Once that build completes and I have a new version of each of my applications that needs to be evaluated, this pipeline is going to promote that change into my dev environment so it can be deployed and tested there. And once that deploy is complete, it's going to go ahead and check the application's health, make sure the deploy was successful and my application is working as intended. At this point, I've configured a human gate into my pipeline. I want to confirm what everything looks like before I decide whether to promote that change to prod. Shape of that's going to be exactly the same. I'm just going to trigger it manually at that point. So that's going to happen automatically once the build we kicked off, where were you? There we are, complete. So it looks like lib hello world finished. And so my applications are in the process of building. You'll actually see here in the build process, all it is really doing is our standard WAR file build for a Java app. So it's running Maven under the hood, but that's all getting built into the artifact itself, so that the pipeline just needs to make sure I can take that artifact and deploy it wherever it needs to go. So how does the deploy happen? Am I deploying to virtual machines, to Azure, to AWS, to GCP, to a container? Doesn't matter in this case. I've configured these applications in a pretty special way. So here's another thing that we can do with Chef Habitat, and we'll illustrate it in Chef Automate. So we can see here, and I'm going to keep my pipeline going in the background so I can see when my job starts. We have all of the applications that I'm running in my environment. So we see our sample node app, we see national parks, I've got a dev environment and a prod environment. And of course, we can see all of the other services running here. National parks in particular is a little bit more complex. It's got a database that it talks to, MongoDB. It's got a load balancer that sits in front of it in case I want to scale out the web front end. And everything I'm managing right now is actually sitting on VMs in the cloud. So I'm using Chef Infra, that's what this config baseline is, also packaged with Habitat, and Chef Inspect. Because it's not just our applications themselves that have a life cycle, but all of the other applications they depend on. And we can bundle these all in the same way. Now, as for what those individual applications or what those individual processes are doing, we can get a little bit more insight on Chef Infra and Chef Inspect here as well. So I can see a better layout of what actual infrastructure I have, the servers that I'm running on, and the infrastructure tab here, as well as compliance settings. And this is the output of Chef Inspect runs, making sure all of my security content is looking good. Ultimately, what will happen here, and it looks like we've had some deploys happening in the background here. Oh, yeah, look at that. Pipeline was too quick for me. So what in the world just happened? So when I deploy my applications, I deploy them with a strategy. And all of my apps here are deployed with an at-once strategy. What this means is when the application gets promoted into the proper channel, so a channel is like a release in my artifact repository, it's going to trigger and deploy immediately. And in this case, all my pipeline did was promote that artifact to a new channel, and then wait for the application to finish deploying and run a health check. If you look here, all it did is made sure the deploy was complete and check to see if the app was healthy for a sample node app. But we saw a little bit of a spoiler in Chef Automate. Things weren't looking so rosy for national parks. And indeed, I see here, to go ahead, something is horribly wrong. The health check returned critical. What does that mean, the health check returned critical? Well, I mentioned before that we can get data out of this supervisor API, and we used it to see what the dependencies were for my applications. I can also use it to see the health information about my apps. In this case, we'll go ahead and look for the status of that health check. It helps if I format it properly. Again, I got to tell it which national parks. It's the dev national parks that I'm looking at, because that's the one that looks like it's failing. Indeed, the health check returns critical. So the application package itself defines what healthy means. All my pipeline has to do is check that endpoint, see what it gets, and then either fail or succeed. So where I ended up was that national parks is going to have an issue. So if I apply the patch to my national parks environment, there's going to be problems. I'm going to defer on this for just a moment. Let's look at sample node app. Sample node app looks healthy across the board. Nothing strange here. So we're going to promote to prod. This time we'll be able to watch what's going on, but it happens pretty quick. Here, all it's doing is running a command to promote to a different channel. That's just an API call to the depot. So that happens pretty quick. Now that deploy is happening. And the fun thing is, so the tool we're using here is Concourse CI, and it does all of its jobs inside Docker containers. What I found was the deploy happens so quickly that this Docker container is going to take longer to finish deploying my pared down CentOS environment than the deploy took. See, already done. So that's literally how fast that deploy went. And we can see here right at the end, it's checking sample node app in prod. It's getting the app is healthy back in return. And again, I can do this same check here. I want to make sure that I'm looking at sample node app, and stable is the channel that I'm watching in prod. And of course, I want to actually hit the prod server. So I'll go to app.prod. Oh, no, it's the group is called prod. The channel is called stable. Remember your API structure, kids. So here I get the OK back. So again, same thing. The logic is the same between my Node.js app and my Java app, because what determines health or non-health, what determines how to build, what determines how to deploy is all defined in my app artifact. This allows me to promote the things that can just take this change automatically. Sample node app is protected from this CVE, but National Parks is going to need some work. So now I can spend my effort where it's actually needed. I can determine whether I need to make an update to the code of National Parks so it can consume this change, or add some compensating controls. Maybe I just need some extra firewall rules, say, to protect this environment while I evaluate. The end result is I spend my time where it's needed, but I don't have that be a blocker to consuming the change where I don't need to make any updates. And ultimately, I can come back into Chef Automate and see the results of all this. So all of my environments now are, if we refresh the page, going to be on the latest release of their respective packages, except for National Parks. So National Parks, we have kept things on the old 1827 release in prod because the 3927 release failed in dev. But 3926 passed in dev for sample node app. So by gum, it got promoted to prod. Within Chef Automate, we get observability into what the live state of our environment is, as well as the history of change that we've seen. So you see it changed from OK to critical 5 minutes and 30 seconds ago. And the same way, we can see the results of each configuration change to the infrastructure with the run history, as well as the audit status in our security and compliance audits and the scan history. And with that, I'm going to hop out of my screen share and back into the slide deck. And we're going to, oh, there's that demo slide. We're going to sum things up when we're talking about continuous delivery for all. So the Chef Enterprise Automation Stack combines all of the things that you've seen today. You get Chef Infra, Chef Inspect, and Chef Habitat, as well as Chef Automate for observability of all three. We also release Chef Workstation as your sort of local development or end user experience. And with those tools together, we can automate how we package and deploy everything we're responsible for. And this is not just for your latest and shiniest applications. This is a process that can be applied to legacy apps, to packaged COTS applications, as well as the sort of utilities and tools applications, agents and the like, that get deployed alongside them. This allows us to make sure every team has a consistent source of truth, and that from dev to operations to security, we have a similar view of the world, and indeed, we're not changing how we deploy things. Every change becomes a deployment event. And we see here, now that we've standardized our pipelines, we can start doing some fancier things, like making sure we trigger a build. So if I have a CVE and a patch that comes in the middle of the night, I get to come in fresh-faced in the morning with my cup of coffee, with builds ready to be evaluated. And it gets deployed consistently to any environment. Applications packaged with Chef Habitat can run on bare metal or VMs, as well as be exported into a variety of container formats, so that this same workflow can be applied, whether you're on premises, whether you're in cloud VMs, or whether you're doing things like Docker and Kubernetes, or deploying into some more microservice-based environments.
So cool, Nick. Really, really love that demo. I mean, obviously, you know, you did a lot of work to get this thing set up and stage a scenario, but you can see how this could really be applied to, let's, you know, taking something like core to so many systems. OpenSSL. Imagine a world where you as a developer, you walk in the morning and you read, you get your cup of coffee and you read that OpenSSL has a vulnerability, and you walk over to the system, to your build system, to see that Chef Habitat has already kicked off a new build of the latest patch of OpenSSL and deployed those in your development. Any system that depended on OpenSSL also kicked off a build and rebuilt an artifact, and it's sitting there in your unstable channel ready to promote into an environment and test it out. I mean, we are at that stage right now, and just really, really excited where we're headed. And with that, I mean, for me, it's been amazing. In the last 12 to 18 months, I've been out in the field all around the world. We've really solidified our products and implementations at our customers. And using the Chef Enterprise Automation Stack, we've seen 100-plus-year-old companies accelerate holistically across their environments, pushing not just modern applications to the cloud fast, but these same old companies are being able to leverage Chef Habitat to automate and continuously deliver old, archaic Windows COTS applications that were previously stuck on platforms such as Windows 2003 and modernize those apps without a rewrite. This is important. You didn't have to rewrite the application at all. We were able to package it in Habitat and then deploy it out to modern platforms such as Windows 2016 or Windows 2019, or even export it into Windows containers. So we're seeing our customers adopting Habitat, being able to move legacy applications as fast, or in some cases faster than some of the modern applications that are being built out inside their environment. So we've included a couple of testaments from our customers here to speak to the business outcomes they're achieving with Habitat, and encourage you to watch these videos if you've got some time. They're both very short, only a few minutes each. But this first one's on Rakuten. Graham Weldon is a member of our community and jumped on early to help out with using Habitat to package applications. And Rakuten's a really interesting company, right? They've been around since 1997, and since that point, they've made over 30 acquisitions, business acquisitions that they brought on board. Now, if you go back to what we were talking about earlier about disparate pipelines across your own environment, imagine acquiring one company, and inside of that company, they've got multiple paths to production. Now do that times 30 and think about all the technology and choices and debt that you're taking on. And what Graham and his team have been able to do is, leveraging Habitat, they're able to onboard application teams from all these various acquisitions and go from code to a deployable artifact in literally minutes. And that artifact can then be deployed into any environment, container, VM, bare metal, wherever it is that they need to deploy it, and then manage it in that same way. So check out that video. It's really great. We've also got Nick Kirschbaum from Alaska Airlines, another short video here. He's talking about Alaska and their journey. They are not a traditional software company, but they are very much, they call themselves a software company with wings. They've got legacy applications, they've got cloud, they've got containers, they really, as he says, everything in between. And in a drive to make the path to production more consistent, so no matter where they're deploying, they've made huge strides by packaging their applications into mutable artifacts with Chef Habitat. And those artifacts are abstracted away from the operating system and can be deployed and managed consistently wherever they're deployed. So really exciting stuff, but what are we going to do now? The best thing for you to do is go ahead and get started.
Yeah. So if any of this sounds like it'd be up your alley, if you're looking at targeting a cloud migration, anyone who's running things on Windows Server 2008 or Red Hat 6 knows that there are end of support events coming right around the corner. So this might be a great opportunity to package those applications and get them migrated to more modern systems. At any rate, whatever your use case, hit us up at chef.io/migration, and we can set up an assessment to figure out how we can get you that speed you're looking for with the safety that you need. Also worth noting, and we're going to dive into some Q&A here, We have a couple minutes, but it looks like we have a few questions we can get answered. I wanted to make sure I gave a nod to, there was a question of whether we offer any training or trials for our software. Short answer is yes. I encourage everyone, if you want to get hands-on with Chef Solutions, to head on over to learn.chef.io, which is Learn Chef Rally. We've got a variety of videos of hands-on walkthroughs, as well as links for setting up formal training classes or joining us in some of the training events we have, including one that just kicked off today. So we have a Learn Chef Rally road trip hitting multiple cities. So if you want to see if Learn Chef Rally is coming to a city by you, head on over to chef.io/road trip, one word. And Scott, the question came in, and I think you were starting to address this a little bit, but how hard is it to get started with Habitat?
Yeah, it's a great question. I think I may take a crack, Nick, at answering two questions there in a row, which is how hard is it to get started with Habitat, and does Habitat work with both Linux and Windows? Oh, yeah, I think they're both related. So this is one of the amazing things is Habitat is really easy to get started. It's a single binary that you download and install on either your Windows laptop or your Mac laptop or a Linux system to develop Habitat automation plans. And those plans are just shell scripts. They're written in the scripting language for the target platform you're automating for. So Habitat works with both Windows and Linux applications that you want to package up. And when you're automating an application for Linux, it's a bash script. And when you're automating for Windows, it's a PowerShell script. And so, when Graham was talking about, onboarding new teams into his environment, the barrier to entry is, does your team know Bash? Does your team know PowerShell? Great, you can get started. Beyond that, it's configuration templates. So it's really very easy to get started with Habitat, and we've got a great community out there. Habitat.sh is our main site for that, but there's also a Slack community and lots of people that are eager to just help you and jump right in there. And all the code, there's a just growing community of community plans. So these are the automation plans to automate common applications, and you can leverage those right now today inside your environment and build common services that are ready to go.
Great.
And so, Nick, there's also this question about CI tools. Do you work with? I think they mean like what CI tools does Habitat work with? And you touched on some of this in your video, but maybe you can dive into that a little bit more.
And I mean, like at a high level, it's pretty easy to integrate with just about anything, right? The Hab utility itself has a curl bash installer that's very easy to do in any sort of task-based system. And all of the health checking I was doing is just via API calls. So there's nothing Habitat specific in that setup. That said, we have some plugins to make that easy and making all the authentication pieces of doing that easy in a variety of tools. So I was using Concourse CI, which has a Hab plugin that I was using. There are Habitat plugins I know for Jenkins and for Azure DevOps. There's probably other ones out there in the world that I don't know about, but yes, we've tried to make it as CI platform agnostic as possible, so that really you don't need to worry about what your implementation is. You can probably make it work with Hab.
Yeah, that's a great point, Nick. We touched on that term shifting left, and we talked about how the responsibility for everything you need to do to automate an application should actually live with the application itself. So imagine a repo inside of GitHub or GitLab, and inside of your repo now you also have what's called just a Habitat directory. In that Habitat directory are all the instructions on how to build it and run it and deploy it. And so your build system, whatever tool it is you're using, the job runners themselves just really need to have Habitat installed on them, that they can then execute a Hab build and kick off and build an artifact and then push that artifact up to the artifact repository. So it really does streamline that whole process from developer laptop. Developers can build the artifact and test it and know that when it goes through the CI system, they're going to get the same result as well. So I think we're just about at the top of the hour. Are there any other questions? Nick and I would be happy to answer them.
Yes, indeed. And we'll be sure to let everyone know when we have the on-demand webinar recording available for folks that weren't able to join us live today. Anything else we need to do to close out, Erin?
No, I think we are good here. Like Nick said, on demand should be available by tomorrow. And we'll be sending out an email so you can watch again. And of course, everybody that wasn't able to attend can watch as well. So you can access it using the same link that you're using right now. And then a heads up that we're having another webinar coming up here pretty soon. It's called Level Up with Chef Effortless Infrastructure, and we'd love to see you at that one as well. So you can find more information about that webinar on Chef Webinars page or our Chef Events page as well. So I'm going to close it out there. Thanks again, everybody. Thank you, Scott and Nick, for a wonderful presentation, and have a wonderful day.
Thanks so much. Take care.
Take care, everyone.